Okay, so for problem 9.5, we're asked to use this figure we have here right in front of us. And it's telling us how are the angular speeds of the two bicycle sprockets shown in the figure related to the respective numbers of teeth, which is NA and NB, right? So they want us to kind of write kind of a relationship between the angular speed and the teeth, their respective numbers of teeth, right? Okay, so let's think this through. So we know that for the big wheel here and for the small wheel here, the tangential speed has to be the same, because if there's 4 links here passing through, there has to be 4 links here. If not, the chain gets too loose, right? This chain here gets either too loose or it breaks maybe, right? So basically what we're saying is that the tangential speed here, right, is going to be equal to the radius times the angular velocity. And now this, let's say if this was A and this is B, right, the big wheel's A, small wheel's B, we can relate it to them this way, right? Since they both have the same tangential velocity, we know that the radius, the product of these two and the product of these two are going to be the same. And by using this formula, we can get a ratio, right? Just pretty much playing around with the formula. You just divide, right? You can divide the angular velocity, the angular acceleration, to both sides, and we just play around with the formula and you get this kind of ratio, right? So now, just to make things a little bit more clear, because we were arranging this one, yeah, this is just I'm just making sure of something. This is the inverse ratio of the radii. Okay, that makes sense. Okay, so now we talk about here, we have to talk about the spacing of the teeth, right? The spacing of the teeth here, right, which is going to take us back to the actual number of teeth, right? So for that, for the number of teeth in each gear, is the circumference of each divided by the number of teeth is going to be that's going to be equal to the distance of each little sprocket, right? And that's what I'm basically showing here. The circumference of the first one of A, the big wheel, over the number of teeth of A is going to be equal to the circumference of B divided by the total number of teeth in B, right? And so what this is saying is that the gear spacings should be similar or the same, right? Now we know that this here, it will cancel out. The 2 pi and the 2 pi cancel out. So now we have r of B over radius of A is equal to the number of teeth of B divided by the number of teeth in A, right, in gear A. So, and that's how we get that's how we get to our last the angular speed, right? When relating it to the number of teeth, we replace the radius with the angular acceleration, or wait, I believe that is the angular acceleration. Sorry, not angular acceleration. This is the angular velocity, right? And then we related that to the number of teeth, and this should be that relationship.